Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Friends, today we are starting a new topic. This name as deflection of beam using energy methods. In energy method, we are seeing here we are seeing over here the virtual work method or unit load method or Castigliano theorem. All the three names are same. In exam, you have written the virtual work method or unit load method or Castigliano theorem. All three names are same. Now in this we have to find the slope and deflection. For deflection we have to apply the unit load, and for slope we have to apply the unit moment. Let's see in details. Now let's start with the, see, this is our question given over here, and now start the solution. Now first what you have to draw, first draw the same diagram as it is and draw here load A and B, and this is D. Okay, now see, this is what support, this is roller hinge support, so that were two reactions. This is your A, this is VA, and this is HA, and this is, see, this is roller support, that's why it will be this. Okay, now first what you have to find, this name as M diagram. M, this is big M, not small m, this is big M diagram. Okay, now what you have to do first find the reactions. First step is find support reaction. Okay, now in support reaction what we are taking moment at A. See, we are finding over here, taking moment at A equal to 0, clockwise positive. Okay, clockwise positive means, now see, we are taking moment here. Okay, so this 10 will become clockwise. See, put a rod over A and apply 10 kN like this, will rotate it clockwise direction. So 10 into 3 force into perpendicular distance, then plus this UDL plus 10 into 4 into 4 by 2. This is nothing but force into perpendicular distance of UDL, then minus VD into 4 equal to 0. This is your VD. Okay, VD into 4 equal to 0. While solving this, you get the value of VD will be 27.5 kilonewton. Okay, upward direction. Now after that, summation Fy equal to 0, upward positive. See, we got the value of Vd will be 27.5 kilonewton. Then this Va will be go minus, sorry, plus Va, this will go minus 10 into 4, then plus 27.5 is equal to 0. Va will be get, the value of Va is 12.5. all the external loads. Now remove the all external loads which is over here. Like see, this is external load means this 10 kilonewton, this UDL, this only. Okay, we have to remove all the external loads and only draw the diagram. Okay, now we are removing all the external load. This will be A, this is B, this is C, and this one is D, and this part is E. E is nothing but this one. This is your E part. Okay, now in this what we have to do, see, now read the question carefully first. See, find the horizontal displacement of roller support means we have to apply the 1 kilonewton horizontal at for roller support. Means roller is where, this roller is here, so we have to apply here horizontally 1 kilonewton. Okay, now while using this 1 kilonewton we have to balance the, see the, here I have hinge support, so this will come, this is also coming, and this is roller support, this is also coming. Okay, so what we have to do, see, this 1 kilonewton is going in this direction. While we are taking X, then this will go this direction, this is also have 1 kilonewton. Now see, then vertical they have no reactions over here, that's why it will come 0, it will also get 0. This is your small m diagram. So sorry, this is a small m diagram. Okay, now after that what we have to do, we have to draw the table first and take the different sections. Let's see how it gets. Now students, draw the table, region, origin, limit, m is at small m, then ei, and signs, follow the sign convention. This means we are taking section at sections, and we have to find that section, we have to find the bending moment over there. Okay, now see what have to come first. See, region, what is our first region will be, see, we are taking first region is A and E, so write it over here, region over here, AE. Okay, now what is origin, we have to take origin. Now take origin as A, this is your origin, A. Your limit will be, in this your limit will be 0 to 3, 0 to 3. Now now what you have to do, you have to take a section A and E like this, and this is as origin. Okay, that this distance is nothing but X, and this is your origin. Now you have to take point here, we have to take the bending moment as C this side, not this side, because we are taking origin here, that's why we have to take this side only. Okay, when we are taking bending moment over here, see what will come, see this will come plus sign, this will come 10 into this distance is nothing but S, 10 into X. See, like this we are taking section over here, this 10 will go like, see, this is your 10 kilonewton. Okay, this 10 will be go like this, na, like this, so we are taking positive, so write it in M, 10 into X. Okay, this is your M. Now let's move to M, then let's move to small m. For small m we are taking section over here, and this is your origin, we are taking bending moment here. So what will come, this 1 into X positive, so 1 into X positive. Now what about EI is constant, so EI as it is. Now we have done with first part. Okay, now let's see the next one. Now see, now what is the region over here, this we are taking region E and B, we are taking region E and B, and what is the origin, the origin will be E, okay, now what is the limit, its limit will be 0 to 2, 0 to 2. Now see, we are taking section over here, and this is the distance X. Now we have to take the bending moment here. When we are taking bending moment over here, we have to see all this one, don't see only this 10 kilonewton, because as you all know, bending moment either you can take left, either you can take right, but whole, not in some part. So okay, so please listen first. See, we have to taking a bending moment over here, so we have to take this all part. This 10 will come in the picture and this 10 also come in the picture. Okay, now let's see how it's come. See, just simply like put here like this. Now see, we are taking moment over here, so this distance will be 10 into this distance. If this is x, and what is this distance, whole distance? This is nothing but 10 into 3 plus x, or x plus 3. We are taking bending moment over here, this point, so we are taking this 10 into 2x. This is directly this come minus. Okay, see, this what will come, plus 10 into this 3 plus x. So x plus 3, distance will be 3 plus x. So right over here, 10 into x plus 3. Okay, x plus 3. Now we have done with this part. See, now we have done with this part. 10 into x, sorry, 10 into 3 plus x means x plus 3, same. Now take this will go this direction, so minus 10 into what will this distance is nothing but x, so minus 10 into x. Okay, now let's move with the small m diagram. A small m diagram, we are taking section over here. This is your origin, this is your x distance. So what will come, 1 into x, 1 into 3 plus x, as this is 3 meter, this is 2 meter, this is 5 meter, I think 4 meter, and this is 5 meter. Okay, now see, we are taking section over here, so what will come the distance, 1 into 3 plus x. This distance will be 3, this one has 3, now this will come plus x. So directly we have to write over here, sorry, 1 into x plus 3. Okay, 1 into x plus 3, 1 into, this is the distance, we are taking section over here, this will be 1 into, this is x plus this whole 3. Okay, now ei will be constant because it's the same. Okay, now let's move to the another part. The other part will be b and c. So write it over here, region will be b and c. And what about the origin now? Now you can take the origin b also, or you can take c also. But see, when we are taking origin at b, this will, when we are taking origin at b, we are taking section over here. This will see, this part is so little bit complicated for us. For time saving, you have to take the origin at c, and you have to see this side, because this side is no load, only one load is there. Okay, now take origin at c. The limit will be 0 to 4. 0 to 4. Now take a section over here. Take a section over here, and this distance will be x. We are taking bending moment over here. Now what will become, see, first this value is coming. This value is coming 27.5 into x positive. 27.5 into x positive. Now after that this UDL will come in the picture. So minus 10 into x by 2. Rearrange it once times for this equation. See, 27.5x minus 5x square, this will come finally. Okay, we have to this rearrange over here. Okay, 5x square. Now after that, let's move to the m1, sorry, small m. For small m, take a section over here. This distance will be x. Take a bending moment over here and see this side. What will come? See, this one is only come in the picture. So force into perpendicular distance. So please listen, students. Don't need to write 1 into this x distance. We want in moment force into that perpendicular distance. That's why we have to take 1 into 5. That's it. 1 into 5. That's it. This is your EI. We have done with this part also. Okay. I hope you are understanding this videos. Now after that let's see with the another part. This region will remaining is C and D. Now we are solving C and D. Origin will be C. Don't take the origin C, because when we are taking origin inside, you have to see all this part. Only take the origin at D and take this one also. This is also origin at D. Limit will be 0 to 5. Now move to this one. We are taking section over here. This will be origin. This is your x distance. Okay. Now you are taking bending moment over here. To see in bending, when we are taking bending moment over here, there is no horizontal load. See, there is no horizontal load. That's why this value will become 0. Okay. Now in small m, take a bending moment over here. This distance will be x. See, in here this 1 is there, so 1 into this x, positive. See, put a like over here and this will come positive, so 1 into. Okay, now we are complete with the table. Now let's see how to put in the equations first. Now see, we have to find the deflection at ruler support in horizontal direction. That's why we have to write y at D. We have to find deflection. Y stands for deflection, D stands for we have to find at joint D, or bracket you can write yd at horizontal. Okay, what is the formula? Our formula will be 0 to L upon EI dx. Okay, now put all the values that is in the table. Take 1 upon EI constant. Take 1 upon EI constant. Now see, right now see, this is going 0 to 3, so limit will be 0 to 3. After that 10 into x. Okay, now this will 10 into small, this m into small m, so 10 into x into this x, so this will come 1x dx. Okay, now see students, we have done with the first part, 10 into x into 1. Now see, this will have done, we have done. Now after that we have to do plus. Now integration, what is this value will be 0 to 2. Now what is this? 10x plus 3 minus 10x. Okay, so write like this, 10 into x plus 3 minus 10x. This will come in the first bracket and this will come in the another bracket. 1 into x plus 3 into dx. Okay, now 1x plus 3. After that plus integration 0 to 4. Now this value 0 to 4, this value will come in the one bracket, 27.5x minus 5x square, and into small m will be 1 into 5, so 1 into 5. After this one, after that plus integration 0 to 5, this will get 0 and this will get 1x dx. This is also with dx. Okay, dx. Now close the bracket. Now you have done with the all the numerical parts and now solve it at one by one. Solve first this part, then this part, then this part, then this part. 90 plus 240 plus 566.66 plus 0. This is value we are getting. Okay students, now we got the value of yd. While solving this, we get the yd will be 896.66 upon EI. Now see, we have to put the value of E and I. Your E value will be given 210 into 10 raised to 3 Newton per mm square. Convert this into kilonewton per meter square. Okay. Now I value will be 2 into 10 raised to 8 mm raised to 4. Simply put the value over here, convert and then put the value. Okay. Now see, I am converting directly. As you all know, E will be 210 into 10 raised to 3, this will be Newton. To form the kilonewton, 10 raised to minus 3 upon 10 raised to 6 upon See, upon 10 raised to minus 6, okay, because this is per meter, so that's why it will come up, it will go plus into 10 raised to plus 6 into this is got with the E value. Now I value will be 2 into 10 raised to 8 into 10 raised to minus 2. This will come in the meter. This will come 21.34 into 10 raised to minus 3 meter. Now YD will be 21.34 mm in this direction. This is your final answer. I hope you understand my videos and please subscribe the Ekeeda channel. Thank you.